Hey guys and girls, wanted to share with you another paying gig we have coming through the shop. It's a relatively simple shaft, 14 and a half inches overall. It's from 1045 steel. As you can see, it has a keyway in this end and two 3/8 holes in this end, 90 degrees apart. A reduced diameter area here. We've gotten this far so far. We have the reduced diameter. Now we're going to work on the keyway here. Let's go over to the mill. Okay guys, we're going to cut our keyway, 3/8 keyway. So the first thing we want to do is find the center of our shaft. Now with your conventional kickover style edge finder, this shaft, the diameter is a little bit too big. I can't quite get the edge finder in there properly to catch that side of the shaft properly. So the solution is our ball bearing edge finder kit. The kit comes with 3 sizes of shafting. So we have the added bonus of once we find our center, we'll use the 3/8 shaft. Once we find the center, we can switch right out to our 3/8 end mill to cut the keyway without having to change the collet. Let me get the edge finder set up here and we'll find the center line of this shaft. So with the ball bearing edge finder, I'm able to get down right on the quadrant of that shaft, and I have lots of leeway. The thickness of the bearing makes it easy to line up on that quadrant. So watch for the stroboscopic effect. We'll find this edge. (960 RPM). Right there, I will zero out my y-axis. Pop over the other side. There, the bearing is just barely touching. Perfect. So I'll use the half function on my y-axis, and we can move to the center and start our keyway cutting. Ball bearing edge finder kit in the link in the description. Right there, 0. Center line of our shaft. I'll cut that keyway and then I'll bring you back. I should emphasize that we can just loosen up this collet. We don't have to take it right out. And we can go directly to our 3/8 end mill. There it is there. Bring you back. Okay, we've got our keyway cut. We've got a key made up. Next thing we need to do is turn our attention to the holes. two 3/8 holes, 90 degrees apart in this end. Okay guys, we're setting up to do our holes. We'll find the end here with our ball bearing edge finder. We want a hole back from the end 1 inch and another one at 4 inch, 90 degrees to this one. We'll find the end here, watch for the stroboscopic effect. Right there, we are 11 millimeters away from the end. Let me set my DRO. Okay, we're done with our ball bearing edge finder. I'll show you the setup here. The question is, we go do our through hole here. We want a generous chamfer. This thing bolts together, so we want a generous chamfer on both sides of the hole. How do we find, once we turn the shaft around, how do we know when we're at 90 degrees? And when we drill the second hole here, we want to be at 90 degrees to this one. With all that in mind, we take advantage of our ball bearing our indexing plates. Let me show you the whole setup here. Okay guys, we got our work set up. We've come in an inch from the end. We have a center drill there. The work is supported with a jack. We have two V-blocks in the vise, 3-point contact. We have a stop against the work here. We can reposition our work in the x-axis. And we have our indexing plate secured to the work. We're going 90 degrees apart, so we've used the octagon shaped indexing plate, and we've gone with the 2-inch. Here's the rest of my indexing plates that I made from my kit. Comes with all 4 pieces, hexagonal and octagon in up to 2-inch capacity. And I've used my machinist square to square up against one edge of the indexing plate. Let's get started. There's our center drill done. We'll go through with a pilot drill here now. And our final size, 3/8. Love. When it's assembly time, the shaft gets bolted inside a sleeve. So we want to give a generous chamfer on that hole. That's worked well. So now, how do we chamfer the other side? This is where our indexing plate comes in. We're up against the stop there. We can release the shaft and the vise. Make sure we're up against our stop again. Re-square on our indexing plate. Okay, we've got our index plate squared up. Now we can do the second chamfer on that hole. Absolutely nothing wrong with that. Love it. Okay, so we'll turn our shaft 90 degrees so we can get to our second hole. Even though we're working on the side with the set screw, there's plenty of room for the blade of the square. So I'm happy with that. We have the shaft at 90 degrees, now ready to do our second hole for time. Okay, we got our hole through. We'll do our first chamfer. Just like that. Now, how do we line up our second side? There we have it. That was the last operation on our shaft. The index plate provided that 90-degree offset. Of course, with the octagon, you can go in 45-degree increments. The kit has octagonal and hexagonal plates. Allows you to put features on a part 60 or 45 degrees apart. I can take this shaft out of the vise, do some kind of second op, and set it right back up again and get registered nicely. So there we have it, guys. A nice paying gig comes through the shop. We are able to go from drawing to finished product with minimal fuss. The ball bearing edge finders let us find center on that larger diameter shaft without having to change out our collet. We were able to go with the 3/8 and do our 3/8 keyway with the same collet. And the indexing plate allowed us to chamfer and drill these holes 90 degrees apart. Thanks for watching. Links in the description. Still have lots of the 3-inch machinist clamps available. Check out the store. Thanks for watching, guys. Enjoy your shop time.